Hello everyone, I'm Kay. Today I'm bringing you a case study on this plaid shirt. Compared to the previous leather case, this one is a bit simpler. For beginners, working through this example will make it easier to understand how to use Substance Designer. Alright, so as usual, we'll start right from the first node. Here, we're using a node called, hold on a second. It's called Gradient Linear. To open it, just press Tab and type RA on your keyboard, and you'll find a lot of gradient maps. Gradient means a gradient map, right? So Gradient Linear is just one of them. It's a linear gradient map. Once we have this node, we can set this part to rotate 90 degrees, which will make it vertical. Then there's another node called Fiber. To get the Fiber node, just press Tab and type Fiber. That way we can bring up the Fiber node without needing to change anything else. Next, we'll blend these two nodes together. After blending, the blend mode is set to multiply. That means the black areas will get darkened, while the white areas will stay the same. This works just like multiplication in math. Black is considered 0, white is 1, and gray is treated as 0.5 or any decimal between 0 and 1. So those areas will get darkened. You can see here, this is the original image and this is the darkened version. This way we can create a small element like this. So that's what a little needle tip looks like. Next, we're going to use a tile generator. The tile generator can take these small elements, like these little ones we have here, and you input this element, and the tile generator acts as a modifier to tile it. Here, we've set the X and Y counts to 400, which means it will be rearranged a huge number of times. And nothing else has been changed. But here, let me see where it is. I've set a random brightness value. Let me turn it down a bit, otherwise it might be too much and you won't be able to see it clearly. So first, we use its random arrangement, right? After randomizing the arrangement, then, as you can see, we set both the width and height to 0.5, and in here, we adjusted the scaling on the x-axis and y-axis to suitable values. Next, let's look at the overall scaling. In the size section below, that's where we adjust the overall size, and we set the overall scale to 6. Alright, then after that, we adjusted its random brightness. When we increase it, you can see that some areas become brighter and some darker, which creates a more random effect. We just turn it up a little bit, just a little. And here, compared to the previous tutorial, we've added something new called the checker mask. That means, originally, when this wasn't enabled, it's a grid arranged in a 200 by 200 horizontal and vertical pattern. But after we enable this checker mask, it will mask out some of the small areas in the middle using a black and white checkerboard pattern as a mask. Let me show you an example. Over here, these areas, this one, and this one, are all present, right? They're all scattered around. But once we turn on the checker mask, those scattered parts will be wiped out. It's like we're erasing each little dot. It's basically the same as shifting by 0.5 along the y-axis. This way, it creates a staggered effect for each little line. Alright, and over here, this is the global opacity, which is basically the overall brightness, right? It's like, how bright do you want it to be? If you set it to 1, you can see that this area becomes really obvious. If you lower it, it's not as noticeable. So if we want it to be less obvious, we set it to 0.45. Other than that, we didn't make any other changes. This is another way to use the tile generator, and it also includes the checker mask. Make sure you pay attention to that. Now, let's reset it. Has it been reset? Alright, so for this use of the tile generator, all the other parameters are pretty much the same. There's not much difference. But here, for the rotation, we've set it to 90 degrees, which basically makes them vertical, meaning the whole thing has been rotated. So it's originally set to vertical. Now, for the horizontal and vertical ones, we've given them a little bit of x2 offset here, just a slight offset. This way, the small horizontal and vertical tiles aren't crossing each other in a perfect cross shape, they're just a bit offset. Next, we apply a max lighten. First, let's talk about what max lighten is. Max lighten is basically when you have 2 pixels. Let me give you an example. So, for example, I have these 2 images, and now I want to merge them together. If we choose max lighten as the merging method, what does that mean? It means that when these two images are stacked together, the operation performed is addition. Then the brightest areas will be shown, followed by the next brightest areas, and finally the least bright areas will be displayed. The advantage of this method is that basically you could say the whole image, right? With this kind of blending, the sphere gets merged into the gradient background. In other words, with this way of combining the two images, you can see that the Phong highlight is the brightest, right? The sphere is moderately bright, so the moderately bright areas will be covered by the brightest areas. This is the same kind of compositing method using what's called a max Latin. You can see the input for this image and the input for this one, because here the brightness was adjusted a bit, right? It was made a little dimmer, while this side is clearly brighter. So this creates the effect where the small vertical line covers up the small horizontal line underneath. And over here, the blending mode is subtract. Subtract basically means to remove, just like regular subtraction. Let me demonstrate it here. If we're subtracting, you can see that it's basically the white pixels here. White pixels are 1, right? So you really need to be familiar with the concept of black and white ranging from 0 to 1. Black is 0, white is 1, and in between you have values like 0.1, 0.2, 0.3, up to 0.9, right? So here, it's like we're taking this as the base image and then subtracting values like 0.1, 0.3, 0.6, 0.9, subtracting 1, right? So this area will turn black, and then we can recombine to create a new image like this. The subtraction here works the same way. It's like we're using this vertical bar to subtract the bar below, right? And that's how we get this image. Okay, then we'll use this image as a base element for it. Basically, one serves as the base image for this, and the other serves as this one's base image, right? Now let's talk about the shape of the base image. We've already finished making these small elements here, so let's discuss what's going on with the base image. The base image is actually just a checker. If we use a table, right, we can get a checker, and then by adjusting its TID value, we can get an image like this. So the checker is a black and white gradient image, which you've probably seen a lot on UV maps. Now, our main approach is to use a safe transform. With a safe transform, you can basically, if you click this button, you'll see what I mean. The area inside the red box is the image we're displaying, but outside the red box is the image after it's been tiled. However, when we use safe transform, we can make adjustments while ensuring that the image remains tiled, meaning it stays seamlessly continuous on all sides. Scaling, or you could say compressing, right? So the logic behind this checker image and this one is actually the same. The tiling itself works the same way. But when we use safe transform, we changed it to 7, right? And over here, we input a shape. Just press the second option in table SHH, which is shape. Then we use the tile generator in the same way, setting 2 tiles in the X direction and 2 in the Y direction, right? Then we just adjusted its scaling a bit, as well as its overall X and Y values, like this. Moved it around, right? We tweaked it a bit, and then just like before, we applied a safe transform node. Now, let me explain why we do this. The final output image here is actually a blend of 3 different materials. One is black, one is a black and white grid, and then there's the blue one, right? So it's the output of 3 different materials. That means we need to define the different positions where each of these 3 materials will appear, right? So here, the image that comes out of the safe transform node from the style generator above defines the position of the black block, and the safe transform here defines the position of a white block. The positions, right? Then, after we blend them together, let's look here first. First, for the position of the black block, we wanted to have some texture, so we multiply it with the image we just had earlier. The white areas will then be multiplied by the base image below, which gives us this kind of texture. Now, this image will be combined with the one below. So the output below is the image we got from subtraction. We then multiply the subtracted image, and in the white areas of this image, you'll get a different kind of texture, right? Then we actually add these 2 images together. It's basically the same whether we use addition or not, because of the overlapping areas. The base image is black, right? Then we add a white image on top. So whether we use max net or just add them together, there's really not much difference. Next, we use a levels node here to compress the black and white values really low. This way, we can get 3 masks, one for the black areas, one for the white areas, and one for the patterned areas. As for the nodes here, I'm a bit concerned. That is to say, when you use a levels node here, since it changes the color pixels, it might affect the edges where the two areas meet to some extent. So what I do is take the position of the black squares defined by the safe transform node and then add it to this image. Honestly, whether you add this or not, the difference is really minor, almost unnoticeable. You can choose to use it or not, just using this output is fine too. This way, we can make sure that the black squares are copied exactly into our tile generator, right? Okay, next, here we use a multi-directional warp, and for the input image, we use this Gaussian noise. Just enter GAU in the table input, and you'll get this image. We can adjust its tiling value, right? Now, why did it look so small here? That's because this thing is set to absolute value. Let me explain this part to everyone. As for this output size, first we have two formats. One is relaxed to parent, which means the parent is basically the area at the top of our screen, inside this parent size. Then there's another one, which is the world size that you set, right? Root size means that when you create a new node, if it uses relaxed to parent, it will be multiplied by 2048, 2010, and 8, right? It changes the overall environment's texture size. Alternatively, set it manually using absolute values. For instance, setting it to 256, a tiny value like this, results in an 8 by 8 pixel grid, which equals 256 total pixels. This way, we can shrink this image. I also mentioned in the previous video that when you shrink an image, it actually becomes blurred, right? So in this case, we can also save a blur node. It's the same idea. We shrink it and then increase its destroy and scale. Alright, and here we use a multi-directional warp. Let's take a look at how it differs from the original image. Basically, it warps our original image a bit based on the black and white pixels of this image. If that's not clear, let me give you an example. Let's use a brick texture. Brick, and then let's use a Gaussian node. Gaussian blur, right? Then we'll use a let's type multi-direction, right? Then we can input it like this, and you can see it will blur our original image. Let's set the intensity a bit lower first. If we turn it up, right, it creates this kind of blur effect. We can also control the direction of the blur. Basically, we're taking these black pixels, let's lower this value a bit, otherwise it might be too clear for everyone to see. For example, let's look at this area. See this part? In the original image, this area is white, right? It's a white area. So after you add this node and increase the value, it will look like it's being dispersed, almost like chromatic aberration. This is a type of blurring effect. And here we can see how much chromatic dispersion or separation there is. For example, if we set it to 124, and if we set it to 1, then it's just a simple distortion effect, right? But if we set it to 4, we get this kind of chromatic dispersion effect. As for the mode, we actually have 4 types. The first one is average, which, like I mentioned earlier, gives you this kind of chromatic dispersion effect, right? And then, when we look at max, we can see that it's actually pretty similar to the non-uniform blur mode we talked about earlier. Wait, no, it's more like the slope blur mode from chapter 1, right? Then, here, if we select color max, it will only erase the black areas. If we switch to the main mode, it will only affect the white areas. When erasing the black areas, it tries to preserve as much as possible, right? If you switch to the chain mode, it kind of twists the image like a distorted bag, making the picture look more stylized or something along those lines. So about the mode, here, the mode we're using is called max. What does that mean? Let's take a look. Basically, it means that we only erase the black areas, right? Our direction warp will only warp the black areas, while the white parts are hardly affected at all. So here, as you can see, let's increase the value a bit. You can see that with this blur, the white spaces and these little white dots are affected much less, but the black areas get distorted a lot more. We just need to turn it up a little bit, just enough to give it a bit of a random texture. The reason we're doing this step, as you can see, is to create some of that effect. Some random distortions, because real fabric, when it's sewn together, can't possibly be so, how should I put it, perfectly regular, right? But honestly, this step isn't super obvious. Whether you turn it on or not, it's pretty much the same, just a little touch for effect. But you really need to know how to use this node, because later on, I'll be using this kind of node effect a lot. And when making stylized textures, this node is also extremely useful. All right, next we've got a black and white image. We can use this image as a mask to define its color. So as you can see here, our input node is a black and white image. The white areas represent our, foreground, and the black areas represent our background, right? Then for the white part in the foreground, we input a blue color, right? A uniform color using the uniform color node, right? The first one is uniform color. Then for the black part of our black and white image, we input black, and you get this blue and black pattern. You can even change its color, change it to whatever color you want. For example, let's change it to red, right? All right, then here we do a subtractive blend with an opacity of 0.29 or 0.29. What does this mean? You can see that both the foreground and background are inputting the same image, but for the opacity, we're using an image that comes from what we made earlier. What was it called? The texture image. This texture image, after we blend it with the other image, we perform the same operation on it, a multi-directional, right? Yeah, the parameters are all the same. Then we apply a levels adjustment to it so it gets an inversion, and we also give it a certain amount of contrast. After that, we use it as a mask for the color here. Why do we do this? Here, I've given a simple example to show everyone. First of all, if we have a blending node, right? If it's set to copy mode and you input an opacity map like this, then it can control the result. You can see that the foreground is pure white, but after inputting the opacity map, it turns into this kind of black and white pattern, similar to the way our opacity input map looks. What this means is that because the white areas of the opacity map in copy mode will extract the pixel positions from your foreground image, right? Basically, the white parts will be displayed like this. The white parts will show up and the black parts will display the background color, right? For example, if we assign a uniform color, let's say we use red or yellow. Well, red is a bit too bright. Yeah, it's too bright, right? So basically, with this opacity in 8P mode, it specifies the foreground and background of your blended texture. It's basically about how the node assigns positions, right? Okay, so the white areas get assigned to the foreground and the black areas get assigned to the background, right? Foreground and background. Now, the way we're using it here is that when both the foreground and background inputs are the same image, we've changed it to a subtract operation. You can see that, basically. How should I put it? Well, let me add another node. For example, like this. It's basically saying that we have an image generated in copy mode, and then we subtract our background from it. So, in other words, this way of connecting things is the same as what we just did, right? This way, you can save a Blender node, one Blender node, but the effect is the same as adjusting it directly like this. And then the opacity here determines how much is subtracted, right? If it's 0, then nothing is subtracted. If nothing is subtracted, we just get a white image. If we do subtract, then based on the black and white pixels, we extract our foreground from it. The white pixels in the opacity map are extracted from the foreground, and then you subtract the corresponding area from your background, which gives you an image like this. So actually, this is basically the same as what we just did. You can see that we're essentially extracting this image. Let's not worry about the foreground for now, just the background. In this black and white, or rather black and yellow image, we're working with these alternating areas. The white areas in the opacity map, the positions of the white pixels. Then you subtract another image of itself. This way we can capture some of the color detail changes, right? And here we have an HSL adjustment, where you can tweak the brightness, the saturation, and the hue. It's basically a color grading node, and then finally we use a levels node. With this levels node, we can adjust the overall, contrast, tweak the contrast and other image properties, right? This is also a color grading node. And then finally, we output to a best color. This way, we end up with an image. Now we have an image with alternating colors. Once we've finished with the colors, the rest is pretty simple, just roughness and metallic. Here, I'm using a node called, it's also a node. This node can't be connected to orders, so it's pretty straightforward. Just use the copy mode like I mentioned earlier, white areas of the foreground, black areas of the background. So by inputting different colors into the foreground and background, you can get different roughness values. You can adjust the roughness here, you can see it here. Here, the darker the area, the lower the roughness. The brighter the area, the higher the roughness. We can use a slider like this to adjust the roughness, which allows us to create different material texture effects. So what is this called? Metalness. Metalness works the same way. We use a single map for both. Here, you can see that increasing the metalness makes it more metallic, right? The whiter it is, the higher the metalness. The blacker it is, the lower the metalness. You can see that this way, we can change the material's metallic texture. Then, let's look at this image again. With this image, we've added what's called a normal node. For the normal node, I've enabled normal intensity here. The higher you set it, the stronger the normal effect becomes. If you don't enable it, there's no effect, right? The higher you set it, the more pronounced the normal map becomes. Right? You just need to find a suitable value. Then there are two types of normal formats, DirectX and OpenGL. Which one you use depends on the software you're exporting to and which format it supports. Generally, we use OpenGL, right? As for where this image comes from, it's also generated by subtracting a max slider, using a base texture, and then applying a multi-directional warp, like you see here. These two are the same, done in the same way, and then you get an image called a Loma map. So this is a customizable color map. And that's basically it for this kind of plaid shirt. Compared to the other tutorial, this one's a bit simpler and more suitable for beginners. After watching, remember to follow my official WeChat account. In my account, you can find the download for this project file in the lower right corner. After downloading it, you can set the nodes aside and try reconnecting them yourself. That way, you can see what differences each node makes. Alright, that's it for this short tutorial. Thank you all.